In this essential question, we're going to learn how we can identify the quartiles in a set of numerical data. So let's talk about what quartiles are. First, take a look at this set of numerical data. The median is the mean or the average of the two middle numbers. That's because we have an even set of numbers. So we had two numbers in the middle, 6 and 7, and the number in between 6 and 7 is 6.5. So the median is 6.5. How many equal parts does the median divide the data? Well, what we've just done is we've split it up into two equal parts. We have this section here from 1 to 6, and we have this section here from 7 to 12. We have two equal parts. In the first part, we have 1, 2, 3, 4, 5, 6 numbers. And in the second part, we have 1, 2, 3, 4, 5, 6 numbers. So we have a lower half and we have an upper half. Both of them are equal parts, and it was the median, the 6.5, that divided them into those two equal parts. Okay, so what are quartiles? Quartiles are the values of the points that separate a set of data into four equal parts. So the median broke it up into two equal parts, but the quartiles are going to break them up into four equal parts. The first quartile separates the lower half of the data into two equal parts. The third quartile separates the upper half of the data into two equal parts. Look below at the numbers to the left of the median. So if you remember, the numbers to the left of the median were 1 through 6. Well, the first quartile is the median, or the mean, of those two middle numbers. In this case, the two numbers in the middle, if we were to cross them off and work our way into the middle, 3 and 4 are in the middle. Therefore, the first quartile is going to be 3.5. And that first quartile divided the data into two equal parts at the bottom. Okay? So the first quartile is 3.5, and what that has just done is it has divided the data up, the lower half up, into another part. So look at it this way. We have our median, who broke everything up into two equal parts. We have our first quartile, which broke up the lower half into two equal parts. We have three numbers here. We have three numbers here. So we have two, oops, I'm doing dollar signs. Three numbers for the lower part too. The first quartile is also known as the lower quartile as well, just because you're talking about the median of the lower half. Let's take a look at the upper quartile now. So the upper quartile, now we're going to look at the numbers to the right of the median. So the numbers to the right of the median were 7 through 12. That's our upper half. And the two numbers in the middle, if we were to work our way into the middle, we have 9 and 10. That means the third quartile is 9.5. That's the number in between 9 and 10. And that third quartile, that upper quartile, divided the data into two equal parts. It divided the upper half into two equal parts. So now, if we go back in, you can see we had our median, which divided it into two equal parts, and then our first quartile, which divided it up into another set of equal parts, and then our third quartile, which divided up into another set of equal parts. We have a total of four equal parts. We have 1 through 3, 4 through 6, 7 through 9, 10 through 12. We have four equal parts, and each part has three numbers. Three numbers here, three numbers here, three numbers here, three numbers here. So that's why they are equal parts. They all contain the same amount of numbers. So let's take a look at page 341. Look at set A. When a set of data has an odd number of values, the median is a value in the set. So if you take a look here, what number is the median, or the middle number of the set? Well, the median is your 210. if you were to cross them off and work your way into the middle, you can see that the median is 210. It's actually a number that's part of the data set. And now when you go to break it up into two equal parts, your two equal parts are going to be, let's change colors here, your two equal parts are going to be the 101 to 137 and the 212 to 284. So your first quartile is going to be the 133 because that's the median of the lower half, and your third quartile is 275 because that's the median of the upper half. Notice that the 210, the median of set A, is not included in the lower half, nor is it included in the upper half. The median separates the data. It does not get included in either of the upper or lower halves. Remember, each set of data needs to be this, or each half of the data needs to be equal. So we have three numbers in the lower half, we have three numbers in the upper half. And so that's what makes it work. Alright, so explain why 133 is the first quartile of the set and 275 is the third quartile. Well, 133 is the median of the lower half, and 275 is the median of the upper half. There we go. Oh, terrible end here. Sorry about my chicken scratch. Okay, now let's look at set B. We have, in this case, an even set of numbers. It says when a set of data has an even number of values, the median is not a value in the set. So if you start crossing them off and working your way into the middle, you can see that you have two numbers in the middle. We have 51 and we have 55. The median of 51 and 55 is going to end up being 53. When you have two numbers in the middle, you want to add them up and then divide by 2, which sometimes it's obvious what the number in the middle would be, but if it's not, that's your strategy. Add them up and divide by 2. So for number 12, explain how to calculate the median or middle number of the set and then calculate the median. So let's see. Add up the two numbers in the middle. Here we go. And then divide by 2. So if we do 51, come on, write for me, plus 55, we're going to get 106, and then we divide that by 2. Oops, I already did the division by 2. And that is going to give me 53. Okay? So 53 is the median of the whole set. So if I go back to this, when I go to break up my numbers into a lower half and an upper half, remember that median of 53 is not included in the lower half and it's not included in the upper half. Keep your median separate. Do not include it in the lower or upper halves. So in this case, 51 down to 26 is part of my lower half, 55 to 87 is part of my upper half, and the median of 53, I'm just going to use a different number to put that in there, or a different color, 53 is in the middle of those two. It's not included in the lower half, it's not included in the upper half. And that makes it even. We've got 3 numbers in the lower half and 3 numbers in the upper half. So each half needs to be even. Okay, and now it's time to find the first quartile. So if I want to find the first quartile, remember I want to cross them off until I get to the middle of the lower half. 26, 51, that means 28 is the median of the lower half. And then the upper half for the third quartile, 55, 87, 64 then is going to be the median of the upper half. So explain why 28 is the first quartile of the set and 64 is the third quartile. Well, 28 is the median of the lower half, and 64 is the median of the upper half. All right, we're going to do one more together, and then you can do the other one on your own. This is plot B. I left plot A for you to do on your own. What we're going to do is we're going to find the median, the first quartile, and the third quartile for all this data. I don't know about you, when it's in a dot plot, I like to take all the numbers out of the dot plot and list them out. So let's see here. We've got 53, 55 with two 55s. 56, 56, 56, two 58s, two 60s, three 61s, running out of space, a 62, and a 64. So now what I'm going to do is I'm going to cross them off until I get to the middle. Let's see. 53, 64, 55, 62, 55, 61, 56, 61, 56, 61, 56, 60, 58, and 60. So it looks like I must have had an odd set of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep, an odd set of numbers. So I have one number in the middle, and that is my 58. Now what I'm going to do is I'm going to figure out what my lower half is and what my upper half is, because in order to get the first quartile and the third quartile, I need to know the median of the upper and lower half. So let's see, I'm going to use a different color here. I've got 53 all the way up to 58 for my lower half, and I've got 60 all the way up to 64 for the upper half. Remember, the 58, the median here, does not get included in the lower half, nor does it get included in the upper half. Yes, this 58 does. That's fine. But the 58 that was in the very middle of the whole data set, that median 58, cannot be included in the upper and lower halves. And by doing that, we can make sure that each half is equal or has an equal amount of numbers. So the lower half has 1, 2, 3, 4, 5, 6, 7 numbers, and the upper half has 1, 2, 3, 4, 5, 6, 7 numbers. So that worked out. Now, time to find the median of the lower half. I'm going to use red again. When I go to cross them off, maybe what I'll do is I'll change the direction of my slashed line so I know if I've already crossed it off or not. So 53, 58, 55, 56, 55, 56, and it looks like this 56 right here is the first quartile, also known as the lower quartile, because it's the median of the lower half. And now I'm going to do the same thing to the upper half. 60, 64, 60, 62, 61, 61, and it looks like this 61 here is going to be the third quartile, also known as the upper quartile, because it's the median of the upper half. And now we've just split up our data into 4 sections. We have this section here, we have this section here, we have this section here, and this section here. We broke it up into 4 sections. So, take a look at your takeaways. We have the definitions for quartiles, first quartile and third quartile, and this part is so very important. Remember, the median is not included in the lower half or upper half. Keep it separate.